Welcome guys, this is Keval Patil and in this video we're going to see design procedure of socket and spigot type Cotter joint. We have seen the introduction of the Cotter joint in last video. So now we will start for design procedure. This is a sectional view of socket and spigot type Cotter joint. This is available in PSG 7.7.140. Okay, so this whole page is available on PSG 7.140 with this diagram. Okay, so you don't have to remember this diagram. This is already available, and while designing the Cotter joint you have to draw this diagram. Alright, now see actually what this diagram is. This part we already seen. This part is nothing but Cotter, and this inside part from this from here, this is nothing but spigot, and this part is male part, we call it as socket. So this one is socket, this one is socket, and inside part is spigot. Okay, so this is half sectional view. Now this P, this is load applied or load on the joint, pull, we can say pull force or load on the joint. D is a small d is a diameter of the rod. Okay, so diameter of the rod. D1, this D1 you can see, this D1, this is not A, okay, this is D1. A is this is A, and this one is D1. D1 is this dimension is D1. It is nothing but diameter of spigot, or you can also call it as inside diameter of socket. Diameter D2 is outside diameter of spigot collar, or you can just call it as diameter of spigot collar. Now we'll move to D1. Okay, D1 is outside diameter of the socket. Outside diameter of the socket. What will be the inside diameter of the socket? It is again D1. Okay, this capital D you can see over here, it is diameter of socket collar. This is socket collar, right? This is socket collar, this is spigot collar, this is socket collar. Okay, now you can see this socket collar and spigot collar touches to each other. Okay, T1 is thickness of the socket collar or spigot collar, and T2 is thickness of the socket collar. Now this A distance, it is distance from the end of the slot, this is end of the slot, to the socket or to the end of the spigot. So end of the slot to the end of the spigot. Now this B is width of the Cotter, T is thickness of the Cotter, and the L, this is nothing but length of the Cotter. It is not mentioned over there, but length of the Cotter is from here to here. It is length of the Cotter. Okay, from here to here it is length of the Cotter, small l. So these are the dimensions in the assembly of socket and spigot type Cotter joint. Now we will move to the first step of the design of socket and spigot joint. Now the first step is step 1, tensile failure of rod. Okay, now just consider this rod. Okay, this is a spigot joint. This is a spigot, this is a spigot collar, and this is rod. Similarly, this is a socket, this is socket collar, and this is socket rod. Both the rods having same, this rod having same diameter. I am just considering this rod. Okay, you can consider any. Now pull forces acting on this rod. Okay, pull forces acting on this rod. Just imagine that. Just imagine while designing. First of all, you should keep this in mind. Failure occurs at minimum cross section area. So wherever there is a minimum cross section area, there failure will occur. Now I'm considering only rod. Okay, so tensile failure of rod. So just consider this rod. Don't consider collar, spigot, or assembly. No need to consider anything. Just consider this rod. Which force is acting? This force. Okay, so draw. I'm just drawing it like this. Okay, this is a rod, this same rod. Okay, and pull force is acting like this. So similarly, Newton's third law, every action is opposite reaction. So one forces are acting this side. So now it is going to break like this. in between, because having same area throughout, so it will break somewhere here, somewhere, anywhere it will break, but it will break like this. And this force is perpendicular to this area, means it is tension stress or tension failure or tensile failure. If it is parallel, if it is like parallel to the force, then it is shear failure. So now in this case it is tensile failure. So what will be the area of failure? That we will see using one animation. Okay, and this animation I took from machinedesign.top website. Machinedesign.top website. It is very good website for animation and videos. You guys go and check. It is not my website. I'm thankful for them for these animations. Okay, see, pull force is acting on the Cotter joint, and this is the failure area. The red area represents the failure area. See one more time. Okay, this is the failure area. So we have seen the animation. In that we have seen the failure area. It is nothing but a circular area. I'm just drawing the 3D diagram. You don't have to draw the 3D diagram in exam. Just draw the 2D diagram or just failure area. It will be enough. Okay, so this is spigot or socket, whatever you can consider, and load is load is at this point. So you can say there also. So it is breaking at this point. It's breaking at this point. Okay, so failure area is something like this. Okay, so I'm just drawing here. So this you can draw in exam. Just simple a circle and failure area with diameter of rod, that is D. Okay, now what is a failure area? A, pi by 4. What is this area? Pi by 4 d square. Now we know thus the force acting is tension, or you can just consider that the failure area, this is the failure area, perpendicular force, then perpendicular force is always tension. So sigma T is equal to P upon area is equal to P upon pi by 4 d square. Alright, so now we know this P given in question, sigma T we know, we can find this diameter T. So just write down, like from this equation, diameter D of the rod is determined. Okay, so next is step 2. Next is step 2, design of spigot. Okay, so see, this is a spigot, this inside is spigot. Now this is spigot collar. We are not designing spigot collar, and I have already told, whenever we are saying spigot, just consider this. Whenever we are saying spigot collar, just consider this, and whenever we are saying rod, just consider this. Now how many dimensions over there in spigot? So this is one D1 A and one more dimension, that is D1, but it is for spigot collar. D2 is also for spigot collar, so we should consider only 2 dimensions, D1 and A. D1 is diameter of the spigot and A is this thickness, this distance, end of slot to end of spigot. So there are only 2 dimensions. For design of spigot, that is T1 and T. Okay. Now first is tensile failure of spigot. Tensile failure of spigot. Now see here, so we're having spigot over here, right? So consider, now I'm not considering spigot collar, neither rod, I'm just considering spigot. Okay, it is tension force over here, tension force from this side also. So tension force from this side also, tension force from this side also. So how it going to break? I already said that you have to keep in mind, or you have to remember this: failure occurs at minimum area. Now where is the minimum area? Now see, this is the section, this is the whole section. Where is the minimum area? It is across slot. It is across slot. So and this is a slot. Okay, this is a slot, and we are applying load like this. So it is definitely going to break like this. Okay, now what will be this area? What will be this area? Now again we will see one animation for this. Okay, just see the animation. Okay, so this red area means failure area. We have seen the animation, and the failure area was like this. Am I right? So it was something across slot. So it was something like this, and diameter is T1, and this thickness is T. Now what is this area? So this area will be the whole circle, that is pi by 4 d1 square minus this area. Now what is this area? So just consider this as a rectangular strip. So what is the area of rectangle? Length into side. Okay, you can say length into breadth. Okay, or one side into the second side. So one side is d1, second side is t. So it is t1 into t. Now see, here we having two unknowns. Okay, d1 also unknown, t is also unknown. Again it is tensile stress, so we know sigma t is nothing but force upon area. So here also we will do same thing. Sigma t is equal to force upon area is equal to force upon, what is area? Pi by 4 d1 square minus d1 t. Now we know that sigma t value is given in problem, okay, or we can find it from PSG if it is not given in problem. P given in problem. So here we having two unknowns, d1 and d1t. So now usually, okay, t value is given. Okay, it is empirical relation. So what is empirical relation? So empirical relations are standards value with respect to the other dimension. Means now we having d1, so we can say t in the terms of d1. So we will call it like t is equal to something 5 d1, or t is equal to 2 d1, or t is equal to 0.5 d1 in respect to other dimension. Okay, so we'll call it an empirical relation. Now where t is equal to 0.3 d, this is empirical relation. Okay, now we know the value of t, we know value of p, we know value of sigma t. So just find out value of t, put over here, and find the value of d1. So from this equation, diameter d1 of the spigot is determined. Next step is crushing failure of spigot. Okay, so we'll see step 3. Sorry, second. Second point, crushing failure spigot. Okay, so this is step 2 only, step 2 second point. Okay, we have 3 points in step 2. Okay, now what is crushing failure? Okay, first I will explain the difference between crushing and bearing. Okay, now assume that two parts in contact. Okay, two parts in contact. Okay, two parts in contact. Okay, now there are two parts in contact, so there is contact stress between them. Okay, so this contact we call it as crushing. Okay, if two parts in contact but without relative motion between them. So without relative motion means they are not moving, they are stationary, they are not having relative motion between them, they are not, like example for bearing, so this is static you can call, so it is crushing stress, crushing. Okay, so two parts just in compression stress, two parts in compression stress, like one part is here, one part is there, and they are having compression load. Okay, now like a screw and nut, they are having relative motion between each other, they are having relative motion, they are like moving like this, they are moving like this, so they are having relative motion between each other. Okay, now so crushing parts don't have any relative motion. Okay, so now see in the assembly of in this diagram, now see this is spigot and this Cotter going to rest over here. Okay, it will be resting in this slot. Now this side of the slot, this side of the Cotter will be in touch with this whole section. Okay, similarly this will be in touch with this section. Now if you remember the diagram, then only one side of the Cotter is touching to the spigot and one side there is a clearance. So this side face will be in contact with Cotter. So now they are not having relative motion, they are not rotating. Okay, they are not rotating or they are not having relative motion, so we will call it as crushing stress. Okay, so this side of the Cotter is in touch, is in contact with spigot. Okay, so this is a failure area. So now, okay, if you remember this, then failure area will be this inside strip, because only this part is in contact. Okay, so draw same diagram, and the contact will be like this, so crushing will be like this. So this is again D1, and this is again T. Okay, so what is a cross section area? So area will be now only this much, D1T, area is D1T, right? So we got the area also. So now crushing stress, so sigma crushing, sigma C or compression you can say, is equal to force upon area is equal to force upon D1T. Okay, now T value we are already knowing, so again find D1, and just compare. Yeah, from here also we found D1, here also D1, so whichever bigger value that you have to consider. So I'm just giving this equation 1 and this is equation 2. So consider larger value of D1. Okay, so from this equation you can find D1, You can find from this equation. Now one more thing you can do over here is just don't use this empirical relation. Don't use this empirical relation, okay, and find this area using d1t. Okay, find the value of d1t. Okay, find the value of d1t, and now put this value over here. Okay, so sigma c is given, p is given. You can find the d1t value. Sigma c is, let's get sigma c is 100 and p is 50. So d1t will be 50 by 100, and this d1t value you can put over there. Then you will have only one unknown in this equation, and you can find value of d1. So both method you can go in different book. You will find both the method. You can use any method. I follow this method. Okay. So now we will see the third point. The third point is shear failure of spigot collar. Now just consider this spigot. Okay, so I'm not done the full view. Okay, so this Cotter will be over here in this slot, and we are just we are just pulling this over here, and we are putting Cotter over here, and we are just pulling Cotter from this side using socket. We are pulling Cotter from this side, and we are pulling this over here. Okay, we pulling spigot in this side, and we are pulling this Cotter this side. So because of this Cotter, what will happen? This whole area, see this area, this area, okay, this whole strip from here, it will come out. Okay, means this whole strip will come out. How it will come out? It will come out like this. Okay, like this. It will come out like this. In this whole area over here, this whole strip over here will come out. So what is the failure area actually? Failure area is this side, this side, this side, and this side. So this is the failure area, this side, and also there is this area also. So two failure area, this and behind this also. Okay, so now we know the diameter. We know the diameter. This diameter is d1. Okay, and this dimension or this dimension is a. Okay, we have seen this here. We have seen this here. This dimension is a. This is d1. Okay, so again I am explaining this because of Cotter. Because of Cotter. Okay, because of Cotter, this whole area will come out like this. Okay, it will come out like this. Okay, this will break, and it will come out. So whole this area will come out. Okay, so what is failure area over here? So you will get the failure area like this. Similarly, one more area like this. So you will have two failure areas because we are having whole strip over here like this. We are having whole strip like this. Okay, so this is first failure area, and this behind is second failure area. So this is A and this is D. So what is the area over here? So area will be 2 into A into D1. So A into D1, this is one rectangle, this is second rectangle, this is first rectangle, this is second rectangle, this is A, this is D1. So A D1 is the area of first rectangle. So we are having 2, that's why 2 into A into D1. So now it is shear stress. Okay, so shear stress is equal to P by A is equal to P upon 2 into A into d1. So from this equation you can find A. Okay, so stress we can find using PSG. D1 we already found, so P is given in question, so we can find A. Okay, so we are done with the spigot, so we can move to the spigot collar. Now step 3, design of spigot collar. So in this design of spigot collar, now this is the collar. We are having only 2 dimensions, that is D2 and D1. We are having only 2 dimensions, then we will get only 2 steps. So, okay, so D2 and D1. Okay, these 2 dimensions we have to find. So step 1, first is crushing failure of spigot collar. Crushing failure of spigot collar. Okay, now see this spigot collar. Okay, we having spigot like this, we having spigot like this, spigot like this, and this spigot collar, let's see, this spigot collar here, this spigot collar here, it is in contact with socket collar. It is in contact with socket collar. Again, they are not rotating, means they are not having relative motion between each other, means they are having crushing stress or compression stress. And what will be the failure area? The area of this collar will be this. This will be the failure area or resisting area. Okay, so now how you will get this? So it is nothing but so this is diameter D2, and this is diameter D1. Okay, so what is the area? So failure area is pi by 4 big circle, that is D2 square minus D1 square. Okay, you can say pi by 4 D2 square minus pi by 4 D1 square. Pi by 4 common, so pi by 4 D2 square minus D1 square. So this is the failure area. So now we know sigma crushing is equal to force upon area. Force is given in question, so pi by 4 D2 square minus D1 square. D1 value we know, P we know, sigma C we know, so D2 we can find. So find D2. Okay, so now from this equation we can find value of D2. Now second point is shear failure of spigot collar. Shear failure of spigot collar. Okay, now see, again I'm drawing this diagram. Okay, I am already having that diagram. So this diagram is already there. Okay, now see this side of socket going to touch this side. Okay, so it's going to apply some force over here. Okay, so what will be the effect of this force? This whole ring will come out of the spigot. How it will come out of the spigot? It will come out like this. Okay, means this section, it was before it was inside, because before it was inside, now it got sheared and it came off, so now what is this failure area? Okay, what is this failure area? Okay, so we know this diameter is T1, we know the thickness is T1. Okay, this diameter is D1, so it is nothing but simple a cylinder. It is nothing but a simple cylinder. Okay, simple outside diameter of, this is outside diameter of cylinder, and this is the thickness. You know the surface area of cylinder. The simple, if you want to know the volume of the cylinder, just find this area, that is pi by 4 d square into length. Okay, into length. Now we want surface area. Find this area, surface area. So what is this perimeter? Perimeter is 2 pi r or pi d, 2 pi r or pi d into length. So similarly we will find here, that is pi d1 into this thickness d1. So this will be the failure area. Okay, so I'm just drawing the same diagram over here. Okay, so you don't have to draw 3D diagrams in the question paper. Okay, so now what is the area? This area is pi d1. So tau is equal to P upon A is equal to P upon pi d t1. From this equation we can find P we know, tau we know, D we know, D1 we know, so find T1. Okay, from this equation we can find T1. Right, so now step 3 is completed. We can move to the socket and spigot design.
Thank you for watching video, guys. Hopefully you have understood the design procedure of Cotter joint. Now in next video we'll see the remaining part, that is design of socket and socket collar and Cotter. Thank you. If any query, please comment and let me know. Share the video with your friends. Thank you.